Hello, everyone. It's nice to see you and to meet you. And if you'd like to, you can have your camera on or off. It's up to you. It is up to you. Can you hear me? Not yes or not no. Yeah, okay, cool. I'm having two screens because I like to see you, talk to you, see the screen, but I also have another screen where I will share what we are going to go over today. So today we're going to go over chapter 1 review. And I would like to do the problems at the end of your section, which are a review set of problems. And I like those problems because it kind of had a variety of problems that you saw for the entire chapter. All right, so if there's no objection, we'll start with some of these problems. And then at the end, if you have any homework problems that you would like to add, feel free to ask them. At any moment, you can feel free to stop me, ask your question, make sure you're understanding everything we're doing. And if you're a bit shy, which I understand, you can always go to the chat at the very bottom of your Zoom screen. There's a chat box. I'll keep it open. Just in case you have a question, you can throw it down in there. It's very important that you ask your questions because otherwise I won't know that there's a problem or something that you don't understand. So please ask your questions. I know it may be intimidating, but be brave, not just for you, but for everyone else as well, because if you have a question, that means someone else here with us probably has the exact same question. So I'll go ahead and start. I know we have 9 participants. I hope we'll get more as the lesson continues. All right, so let's continue with what we're going to go over today, chapter 1, practice test. I'm sharing my screen so we can work this out together. Let's do some of these problems. So let's take a look at these problems. They're asking us to graph the following lines. Well, as you went through these sections, you talked about different ways of graphing. Let's quickly list those different ways of graphing. So one of the ways is if we have y equals mx plus b. And we can easily point out our y-intercept and our slope. And with that piece of information, if I start with first graph my y-intercept, and then second graph your slope, I can graph my line. Another way I can go about graphing is I can use my intercepts. A second way to do is your intercepts. So we see that we can use an x-intercept. So to find your x-intercept, you let y equal 0 and solve. And to find the x-intercept, we let x equal 0 and then we solve. You get 2 points that are on the x and the y-intercepts. And third, you can always do a chart and pick points for x and pick points for y. And you can create coordinate points. Okay, so let's go ahead and start. The first problem, I see that's written in slope-intercept form. So with that said, it might be the first way to graph that would be the best for us, because I can easily pick out the slope and the y-intercept. This tells me that my slope is 2, and then my y-intercept is 3, -3. Okay, so let's begin by first graphing our y-intercept. So along our y-axis, which is this vertical one, I want to locate -3. Okay, -3 would be right here. That's going to be a point on our line. Next, I want to use my slope in combination with that slope definition of rise over run to find more points. All right, second, we have a slope of 2. Let's write it as a fraction, so let's write it as 2 over 1. That way I can use my rise over my run. That way I know that we're gonna go, since it's a positive 2, I'm going to go up 2, and since it's a positive 1, I'm going to go to the right 1. So I go up 2, 1, 2, and then to the right 1, 1. So that's my new point. Let me erase those little notes that I made. Now we can go ahead and graph our line. How many points do you need? I say you can get by with 2. I know there are some instructors who are super picky, super strict about how many points they have. 2 is more than enough for me. So let's go ahead and connect those points. We're done. We graphed that first one. Now let's continue with B. So for B, this one's different. It's different because we're used to seeing 2 variables when we graph a line, an x and a y. Notice that we only have 1. When we have 1, that means we're going to have a special type of line. These 2 special types of lines are vertical and horizontal lines. And just as a quick reminder, if I have y equals a number, that's going to be a horizontal line. If I have x equals some number, whatever number it may be, it's going to be a vertical line. Okay, I have y, so I know it's going to be a horizontal line. Oh man. I know it's going to be a horizontal line. So we have a horizontal line at -4. So horizontal means this way, right? So we have a line going that way at 4. So -4 would be 1, 2, 3, 4. That would be -4. I have a line going across that way. Let me erase my little note. And that's it for B. Okay, let's continue. I have 5x minus y is equal to 1. All right, well, I see that y is almost solved. It's almost by itself. So why don't we solve for y? Let's make that our goal. Let's solve for y. And then let's go ahead and graph using our slope and y-intercept. Okay, so I have 5x minus y is equal to 1. Let's go ahead and get y by itself. So I need to move that 5. I need to move that 5. So we do minus 5x minus 5x. That's now 0. And we have negative y is equal to, let's write our x first. So it looks like our slope-intercept form. Minus 5x, that one is positive, so plus 1. Okay, last bit. To get y by itself, let's divide by a -1 on both sides. So that makes my negative, divide to make 1. And we're left with y is equal to 5 divided by 5 is positive, so 5x. And -1 divided by 1, we get -1. And yes, I drew a heart, so you know that your denominator applies to everything in the numerator. In this case, it's 2 terms. Okay, we have our graph. So now we can easily point out our slope and our y-intercept. Our y-intercept is -1. So this tells me you have the point 0, -1. And your slope is +5. If you write it as a fraction, it'll be 5 over 1. And if we're thinking of our rise over our run, it's a +5, so we will go up 5. It's a +1, so we will go to the right 1. Let's go ahead and graph. So for our graph, we have a y-intercept at -1, and then I'll go up 5 to the right 1. So 1, 2, 3, 4, 5, and to the right 1. That's my new point. And it's nice that we have this grid, so I can actually count and not have my poorly drawn grid. So let's connect them, and we have our graph. Let me erase my little work, my little scratch work. There we go. Any questions on this problem? Problem 1C? All right, if a question comes up, you can always speak up or use the group chat. Okay, this next one. 2x minus 3y equals 9. So for the sense of using some variety, let me try to approach this one using intercepts. Yes, you can go ahead and solve for y and find your slope and your y-intercept that way, but let's just change it up. Just so you can see it be done together. So to find the intercepts, I want to find my x and my y-intercept. And that's going to tell me the point that falls exactly on this x-axis and exactly on this y-axis. Okay, let's begin. So let's find the x-intercept. Now a quick note, to find the x-intercept, we're going to let the other letter be 0. So let y equal 0. That's my little note. All right, so we have 2x minus 3, and then we're going to multiply by 0 equals, I need to be careful with my hand. I have a little wrist stress. Maybe I'll use that. Okay. Is equal to 9. Okay, well, that's 0, so that's gone. We're left with 2x is equal to 9. Divide by 2, divide by 2. We're left with x is equal to 9 over 2. If you want to get a sense of what that is, you can always graph it as, or write it as a mixed number. How many times does 2 go into 9? Well, 2 can divide 8, so that's 4, and I'm left over with 1. So 4 and 1/2. So if I want to plot it on my x-axis, so on this one right here, I need to find the point positive 4 and 1/2, which would be about here. That's my x-intercept. So that's my 9 over 2, or my 4 and 1/2. Now let's find my x-intercept. So to find our y-intercept, we're going to let the other letter be 0. So let x equal 0. Okay, if x is equal to 0, we're left with 2 times 0 minus 3y is equal to 9. And then we go ahead and solve. So 2 times 0 is gone. We're left with negative 3y is equal to 9. We divide by negative 3, divide by negative 3, y is equal to negative 3. So along my y-axis, which is this one, you want to find the point negative 3. So here we are, negative 3. We connect them, and that's our graph. So it's just another way to graph it. This is using your intercepts. We connect our points, and we got it. Okay, now I'm gonna start jumping around just to make sure that I don't bore you to death and bore you to sleep. So I'll start skipping around. I'll go ahead and do 2, B, and C. Those are 2 I'm going to do for number 2. Let's go ahead and do 2B. Our instruction tells us to find the slope-intercept form of the equation of the following lines. So for B, I want the slope-intercept equation, y equals mx plus b. Given these pieces of information, I want to make sure that it includes those points. So I'm creating a line, and in such a way, those 2 points are within that line. Okay, so I need a slope and a y-intercept. I'm not given a slope, so I need to find that slope. My slope is found by y2 minus y1 over x2 minus x1. So we have x1, y1, x2, y2. Let's go ahead and substitute those values. Y2 is 6, y1 is 2, x2 is 1, minus x1, negative 1. Be careful with those negatives. And so my answer is 6 minus 2 is 4, 1 minus 1. You add the opposite, and we're left with 2. So my slope is 2. That's part of my answer. I still need to develop this equation. I can use another equation that's called the point slope formula that says if I have a point and a slope, I can create an equation of a line. That formula is y minus y1 is equal to m times x minus x1. And the values we need to fill in are my y1, m, and x1. And we fill those in using our slope and any other point that we want. It doesn't matter which point you use. I'll use that first one because it has smaller numbers, negative 1 and 2. I'll use this point. Okay, if we continue, we're left with y minus my y1 is 2 is equal to m. My m is 2 times x minus x1. x1 is negative 1. If you don't like negatives, you could have chosen that second point where you don't have negatives. They'll produce the same answer. All right, let's clean this up. So this is now a positive, right? Let's distribute in that 2. So we're left with 2x plus 2 and y minus 2. Okay, I need to get y by itself, so let's move the 2. Plus 2, plus 2. And we're left with y is equal to 2x plus 4. And that is our final answer. Okay, let's go on and look at C. C is asking for a point or a graph, no, an equation that passes through the point 2, negative 4, and is parallel to 3x plus y equals 5. Okay, if it's parallel, that means they have the same slope. So I need to steal the slope. Let's start off by solving for y. So minus 3x minus 3x. Y is equal to negative 3x plus 5. So if it's going to be parallel, my slope needs to be the same. So I'm stealing that slope of negative 3. Now let's go ahead and create my line. We'll use the same equation as before. Y minus y1 is equal to m times x minus x1. I'm only given 1 point, so I'm forced to use that point of 2, negative 4. And I have my slope that I stole of negative 3. Those are the 2 pieces of information that I need. So we have y minus y1. y1 is negative 4 is equal to m. My m is negative 3. X minus x1. x1 is 2. Okay, let's clean this up. So I have y, 2 negatives, we have plus 4. I distribute that negative 3. I have negative 3x plus 6. Last piece, let's get y by itself. So let's subtract 4 to make that 0. Minus 4, we get 2. And our answer will be y is equal to negative 3x minus 2. Alrighty, let's go ahead and move forward. Let's continue with quadratics. For these quadratics, I'll do A and C, unless someone wants to see more of them. Okay, our instructions read, graph the following quadratic functions by finding the vertex and plotting 2 points using symmetry. All right, so the reason why I want to do those two is because they're giving us a quadratic in 2 different ways. We know it's a quadratic because an exponent that we see is of 2. So we have a quadratic. Quadratics are a U-shaped figure that can open up or down. What's nice about this first one is that I can easily find the vertex. That vertex is your peak of your graph. Your vertex is always h comma k. So that's what's nice about the first one. The second one, I need to do some work to find your vertex. To find your vertex, you find h with the small, short little formula of negative b divided by 2a. And then to find k, you plug that back in. Okay, let's go ahead and do these 2 problems. So we want to, our question wants the vertex and 2 points using the symmetry. Let's do A. So our vertex. I see I have some people here. I'm going to make you type into the chat box. There's no right or wrong answer. Well, there's a right answer, but you don't, I just want you to participate. So can you type in what our vertex is for number 5, 5A? So I see 1 answer. So Armani, Nikki, Brandon, Dylan, Aubrey, Karen, Veronica. Let's see some answers. I'll wait for 2 more, then I'll move forward. Okay. I like that all the numbers I saw have a 1 and a 3. So that's good. It lets me know that you're somewhere near that neighborhood of what we want. Now, let's be very careful. Because that x minus 1 is in that parentheses, it's weird. It causes a sign change. And it causes sign change because our standard formula has a negative. So while we see -1, my h is going to be +1. Now, my k, it's whatever number it may be. If I see -3, it's -3. So we see our answer is +1, -3. Okay, so let's graph that. +1, and then I go down 3. Here we go. All right, now we want our axis of symmetry. But before that, let me ask you, does it open up or down? Cool, thank you so much. It opens up. How do we know it opens up? If it opens down, we'll have a negative in the front. So that lets me know it opens down. If it doesn't have one, then it opens up. That's it. So it opens up. Okay, let's find more points. So I know it's going to be a U-shaped figure. I just want a couple of more points to figure out what it's going to look like. I know I have an axis symmetry. So this means that this U-shaped figure has a mirrored reflection. It goes straight across the vertex. So I'm going to draw a line that goes right through the vertex. So it goes right through here. That's your axis of symmetry. What is your equation for your axis symmetry, or what it's labeled as? It's always x equals your h. So what is our h? Our h is -1. Oh, I drew it wrong. Or I wrote it wrong. It's +1. Here, it's supposed to be positive, right? There was negative there. Positive. Let me erase that. That was supposed to be 1, not -1. Okay. Now I want to pick more points. When you're working with me, I want all of you to be mathematicians. And mathematicians, if there's an easier way or a lazier way to go about it, we do it that way. So because I know we have a mirrored image, I only really need to pick one point. Let's pick the point that would make it easiest for us. What if we pick the point 0? So let's plug in 0 into our function. F of 0, let's just plug in 0 for x, see what we get. So I have 2 times 0 minus 1 squared minus 3. Let's clean that up. 1 minus 0 is -1. So I have 2 times -1 squared minus 3. Now here, be very careful of your order operations. So I first have to do exponents before I multiply. -1 squared, well, that means -1 times -1, because it's +1. So I have 2 times 1 minus 3. 2 times 1 is 2. So I have 2 minus 3, I get -1. This means I have the point 0, -1. Let's plot that. 0, -1. So we have it right here. Okay, we have a mirrored image. So if this one is 1 away from our vertex, it's going to line up exactly 1 away to the right. So I have this point right here also. And we have enough to graph our parabola. Let me erase my little notes. So now we have enough points to graph them. So we have our parabola that opens up with a vertex of 1/3. 1/3, not 1/3. And we technically only found one point, and we used our idea of symmetry to kind of match it over on the other side. Okay, let's go ahead and do C. Now, what's different about C is that it's not in vertex form. So I have to do some work to find that vertex. We have a formula we use. So we're going to use that formula to find the H. Now, what is this A and B that I see in that function? A and B comes from our points. So, well, from our equation, I'm sorry. My A would be -2, my B would be -8, and my C would be -3. That's where I get those numbers. They're the coefficients of our quadratic. All right, let's plug them in. So I have negative, and my B is -8, divided by 2 times A, and A is -2. All right, so if we work that out, a negative times a negative gives us a positive, so we have +8 divided by 2 times -2, -4. This gives us -2. So that's a big piece of my vertex. That's my H. Now to find my K, I have to plug it back in and see what my answer is. Okay, let's do that. So I want to find P of -2. So let's plug that into our equation. I have -2 times -2 minus 8 times -2 minus 3. Okay, let's solve for this, and let's keep in mind order of operations. So we have -2 times -2. Oh, I forgot that square. -2 times -2 times -2 gives me +4. -8 minus times -2 gives us +16 minus 3. All right, so we have -8 plus 16 minus 3. -8 plus 16, that gives us 8. And 8 minus 3, we get 2. So that is our K for our H comma K. So I can say that I have a vertex of -2 comma 2. Any objections?
We get 5 because 8 minus 3 is 5.
Oh, thank you. I think I got ahead of myself. I thought of 5 and then subtracted 3. So what your class? Okay, so your classroom was saying is 8 minus 16 is -8 minus 3, oh, +8 minus 3, we get 5. So my K is 5. Thank you.
On the quiz, the last one you had on there was like this, and I kept going through the video, and you were doing them with -b/2. Where did the A come in?
Negative or b/2 comes when we do completing the square.
Yes.
Yeah, for we find the vertex is -b/2a. Is that for you?
Yeah. So then I messed up on my quiz because I did the -b/2, not over 2a.
Okay, well, you can go ahead and resubmit it. There's no limits on submissions, and I haven't graded them, so you can still fix it.
Thank you.
Yeah. Okay, so we have our vertex. Now we're left to the question. And I know it sounds silly. I know you know this answer, but ask yourself this because it's a good checkpoint question. Which way does our graph open, up or down?
Down.
It opens down. Now, why it's so important? Sometimes we graph it and we can go through the process, but we can make a silly mistake. If you make sure your answer matches the way it should open, that's a good indicator that you're on the right track or that you need to fix something.
Sorry to interrupt, Professor, but I don't know if we're on that part yet. But how do you find the y-intercept when it's not given?
When it's not given? Well,
Yeah.
the y-intercept, we always find it the same way. You let x be 0. So
Okay.
if x is 0, I like that you mentioned it because we can potentially find our other point. I'll get to it next, yeah?
Okay, yeah.
Okay. So we have our vertex at, I wrote it down already, -2 comma 5. -2 of 5. 1, 2, 3, 4, 5. I know up and down, and let's label our axis of symmetry. So it's a line that goes right through the vertex, and it's x equal to whatever your h is, so -2. Now I have to pick another point. Your classmate was like, hey, how about that y-intercept? How does that come to play? Your y-intercept is always found by letting your other letter be 0. So let x be 0. Now we're in function notation. So even though I have p of x, that's the same as our y. So to find our y-intercept, we just let all x's be 0. And that's a good point to use if we're in this form because that always leaves you with your c. So your answer is going to be y is equal to -3. Let's do the work for it in case you're like, hey, where did that come from? All right, so this means let x equal 0 if we're going to find our y-intercept. So we have y, or our function notation, is equal to negative 2 times 0 squared minus 8 times 0 minus 3. Okay, well, that's being multiplied by 0, so that's gone. That's being multiplied by 0, so that's gone. And we're just left with negative 3. So I have y equals negative 3. Cool. All right, so let's plot it. That's right here. Now, what's nice about labeling your axis symmetry is you can much easier see how many points away it is from the axis symmetry. So as I'm looking at this is 1, 2 points away. So since it's a mirror image, it's going to match up 2 points away on the other side. So I have another point here. Cool. Now I can connect my U-shaped figure. Let me erase those silly markings to show the jumping of the units. Okay, I have my parabola. My parabola is a U-shaped figure that opens down, in this case, with a vertex of negative 2, 5. And we used our intercept to find another point. Good stuff. Any questions about C? All right, so I see that someone else had a question on the y-intercept and we touched on that. So thank you for asking. Now I see the question that says, I believe it's the C. Oh, answering to her, got it. Thank you for helping her out. Okay, let's take a look at C. I'll go ahead and do 6A. Our question reads, determine whether each function has a maximum or a minimum and state what it's the maximum or minimum. So let's talk about maxes or mins. In a very general sense, I'm going to do some notes right here that I'll erase. Our parabolas can open one of two ways. We'll talk a bit more back when we get to chapter 6 or 7. But we go about it by looking at our options. So my parabola can open down or it can open up, right? With each parabola, we have a vertex, and your vertex, it's always your peak, your highest or your lowest point. So I have a vertex here and a vertex here. If it's opening down, that vertex is the highest point, right? So it would be a maximum. If our parabola opens up, then our vertex would be that lowest point. So that would be a minimum. So that would be a min. Alrighty here, a min. Now when it's asking for a maximum or minimum, it wants the k of your hk of your vertex. So all you have to do is find the vertex and we want the output, the answer for it. So that would be the k. So you want the k from the h comma k. And that would be a max or a min. If you ever get thrown off, because sometimes I know I see the negative and we think, oh, that's the minimum. But really, if it's opening down and it has a negative, it would be the maximum. If you're ever thrown off by it, you can always just sketch little dummy parabola and see, do the reasoning behind it and see, do you want a max or a minimum? Okay, so let's take a look at A. This parabola, I'm going to do a really dummy sketch just so I can reason through it. It has a negative, so I know it opens down, right? Okay, cool. I know it opens down, and I'm going to have a vertex. My vertex is going to be +5 and 7. Now, because it opens down, this is going to be a high peak. That's going to be a maximum. So I would say my answer would be that we have a max at 7 because it's the k. And for the maximum, we want the output, the answer for it. So that would be the 7. And that's it. You find your vertex and it's your k. Now, let's get to those inequality questions because I know that's where a lot of you are like, That's probably the hardest part of the chapter, so I know that's where most of the questions are. I see some questions on the chat, and it says, how do you find the second point using the axis symmetry? All right, let me go back to one of the problems before I move forward. So for this last problem, we found this point using my y-intercept, right? Now, I don't want to, and I'm guessing you don't want to, plug in a value, do the work, the algebra to get another output. So I see how many points away it is from my vertex. Now, my vertex has a cool line going through it, so it's easier to keep track of. That line is your axis symmetry. It tells you it's a mirror image. This side is the same as that side, right? All right, so if this one is 1, 2, it's 2 units away from the vertex, and we have a mirror image, the other point is also going to be 2 units away. So from our vertex, or we can use our axis symmetry to guide us, it's going to be 1, 2 units away. So that's how we can use symmetry to take one point and match it to the other side. I hope that answered your question. I see another question that says, oh, you were just answering the question above you. Thank you. Okay, let's move over to the last bit, inequalities. I'll try to do all of these because I know it's good to see some variety. So before we continue, let's set out some basics or some structure for interval notation. Right at the very bottom corner here. So we have Candy. So for interval notation, we have open and closed intervals. For open intervals, that's when I have something like less than or greater than. There is no equal to. When there is no equal to, in our graph or in a number line, we represent it using an open circle or a parentheses. And that translates to interval notation using parentheses as well. We can also have a closed interval, and that's going to be your equal to's. So you're less than or equal to, you're greater than or equal to. When we graph it, we don't need to have a hole or an open circle. You can just graph it all the way through, or if you're using it as a point in a number line, you can just do a solid circle, a solid dot. The way that translates for us in interval notation is that we'll use brackets. Now, one last piece. When we're looking at our graphs for quadratics, we want to give a super rough sketch, but most importantly, I want to know those x-intercepts, those zeros of my parabola. When I have my graph on your x-axis, focus only on the x-axis. Now, I want to see where it's above and when it's below. If it is above, you're going to have an inequality such as greater than or equal to. If it is below, you're going to have an inequality like less than or equal to. And we're only care about our x-axis and seeing what's above and below our graph. So we're going to give a super rough sketch, mainly focusing on our zeros. Okay, keep this in mind. Maybe as you're working through the rest of chapter 4, if you haven't done so, write it on a post-it. Let's take a look at these questions. Let's take a look at A. So I have x squared plus 6x is greater than 7. Before we begin, we have to make sure it's equal to 0. And that's going to be our base. So I have, to move that 7, so I have minus 7, minus 7. I have x squared plus 6x minus 7 is greater not equal to, greater than -7. Oh, that's gone, 0. Okay, so we want to, because it's greater than, I'm going to make the note, I'm looking for what is above the x-axis. Why? Because I have a greater than. This greater than tells me I want what's going to be above the x-axis. Okay, now I need to find my x-intercepts. So I need to find my zeros I needed to solve. Okay, so now I need to solve for x squared plus 6x minus 7. I want to see when it's equal to 0. So now let's go ahead and solve. Okay, let's see if we can factor this. My leading coefficient is 1. So I want to see what numbers multiply give me 7, but add to give me positive 6. So 7 and 1 work. I can make my 1 a negative, so that 7 times -1 is 7, and 7 plus -1 is 6. Cool. So this factors to be x plus 7 and x minus 1. We set each one equal to 0. So I have x plus 7 is equal to 0. X minus 1 is equal to 0. We solve for x. So minus 7, I get x is equal to -7. Plus 1, x is equal to 1. So these are my zeros. Now I'm going to do a super rough sketch. Now, does your parabola open up or down? Well, looking here, I see that there is no minus, so I know it opens up because there's no minus to begin with. So my super rough sketch for my graph with my zeros at -7 and at 1. And I know it opens up. So super rough sketch. I don't care about the vertex. I don't care about mirroring points. All I want to see is what's happening and where those zeros are. So I have a 0 at -7 at 1, and I want to know what's above my x-axis. I'm concerned with what's going on above my x-axis. That's what I want. So I see above my x-axis, and I want to focus mainly on my x intervals. So I see that I start at 7 and at 1. So do you see how your parabola is going on forever? Forever starting at -7, and it's forever going up. And as you pick a smaller number like -8, -9, -10, -11, -12, you can continue on forever. You're still going to get an output going up. So this would be written for your answer as -infinity to -7. Infinities always have a parentheses, and because there's no equal to, that would be a parenthesis as well. Okay, we have a break, so you write a U for union. That's always necessary for breaks. Let's continue going on. So we see that we have our other arm from our parabola that's also going up. So we continue with that same reasoning. We see that as we pick a number bigger than 1, it's going to keep going up. So if I pick 2, 3, 4, we're still going to have a point that matches it. So that would go from 1, and you continue on forever. So from 1 to infinity. Infinities always have a parenthesis, and because our equation didn't have an equal to, 1 also has a parenthesis. So this is what we're looking at for our graph. All right, let's continue with B. Same idea, I first have to set it equal to 0. And let me erase these side notes that I have here so I can write more. So let's begin by setting it equal to 0 by moving that 2. So -2, I have 4x squared minus 7x minus 2 is less than or equal to 0. So I know from just looking at this that we want to focus because we have a less than on what's below the x-axis. That's what we want, what's below the x-axis. I need to find those zeros because we're talking only about our domain, our x-axis. So let's go ahead and solve. So I have to do some work. My leading coefficient is not 1. So I need to multiply my a and my c, so we get negative 14, and my middle term is negative 7. So what numbers multiply to give us negative 14 that add to give us 7? Oh, I multiplied wrong. It's 8, not 14. We have a times c, which is 4. 4 times negative 2 is negative 8. I don't know where I got negative 14 from, I'm sorry. Okay, so negative 8, what numbers multiply to give us negative 8? That to give us negative 7. And that's 8 and 1. So if we pick negative 8, that will work out. Okay, because we have that AC form, I need to replace that middle term with a negative 8 and a 1. So that's 4x squared minus 8x plus 1x minus 2 is equal to 0. All right, we proceed by factoring by grouping. I group my first two and my last two. So I can factor out a common factor in the first two, and that's 4x. So I have 4x, and that'll be x minus 2. I can factor out a 1, so I'm left with x minus 2. So this factors to be 4x plus 1, and then what's in the parentheses, so x minus 2. So our zeros, I need to set each one equal to 0. 4x plus 1 is equal to 0, and x minus 2 is equal to 0. Okay, let's solve. So I do minus 1, 4x is equal to negative 1, divide by 4, divide by 4. X is equal to negative 1/4. That's one of my zeros. Let's move the 2 over, plus 2, plus 2, x is equal to 2, and that's my other 0. Okay, super rough sketch. Look at your function. I know it opens up because there's no negative, and I have my zeros. Okay, I have my zeros at negative 1/4 and at 2, and my parabola opens up. Okay, and my interest, it's what's below the x-axis. That's what we want, below the x-axis. So I want to see what's going on down here. Okay, I want to focus on those points where it begins. So I want to focus on that 1/4 and at that 2. So I see that's only a very small number, right? Because it doesn't have those arrows that we connect to pointing up or pointing down. So our answer would be negative 1/4 to 2. Now I have to think about whether I want brackets or parentheses. Because we have that equal to, we know we want brackets. So my answer would be bracket 1/4 to bracket 2. All right, I'll do one more. I said I was going to do all 4, but I think I'm going to do something more with this. So let's take a look at C. It's solved for 0, great. Now we need to find those zeros. So we set it equal to 0. I have negative x squared plus 6x minus 9 is equal to 0, and we solve. All right, so let's go ahead and factor out that negative. but you don't have to. You can work with it. But I want to do this so I can just work with that and factor. All right. So I think what numbers multiply to give us 9, but add to give us -6. That's 3 and -3 and -3. -3 times -3 gives us +9, and -3 plus -3 gives us -6. Okay. So we can divide out that -1 so that it's gone. And we have, oh man. There we go. And so this factors to be x minus 3. X minus 3 is equal to 0. We set each one equal to 3. So I have x minus 3 is equal to 0. X minus 3 is equal to 0. You get x is equal to 3, x equals to 3. It's the same point, right? Yeah. So what that means is I only cross my x-axis at that single point. Let me do my rough sketch. So my parabola, this tells me it opens down, right? Because I have a negative. So it opens down and it only touched the x-axis at 3. So my graph looks like this. And that's not an open circle, it's a closed circle because I have that equal to in my function. Okay, now let's take a look at what we want. We want those numbers that are greater than. So we want those numbers above. You want those numbers above. What numbers are above the x-axis or at the x-axis? So on our x-axis, we only have 1 point. My x-axis only has that 1 point at 3. So what is my answer? My answer is just 3. And because it's a single point, we'll use a curly bracket. Now, what if there wasn't an equal to and there was just a greater than? Then that would be an open circle and there would be no point touching the x-axis. Nothing. So if that were a greater than and not a greater than or equal to, then it would be no solution. There'd be nothing. Nothing that fits that criteria. Just wanted to mention that. Okay, so this was a quick chapter 1 review. I just want to do some problems, kind of walk us through it, make sure we can voice our questions, or something funny happens, you can ask the question then. Now, something I'm going to do that I did for my summer classes is I would make the chapter review portion at the end of the chapter extra credit, and I'll do that as well. I did a lot of them, but I didn't do all of them. So for 1 point extra credit added to your exam, when we have an exam 1 after chapter 2, if you complete chapter 1, if you complete the chapter 1 review or the chapter 1 practice test, you'll get an extra point added to your chapter 1 and 2 exam. I'll create the assignment once we log off from Zoom. So in case you want some extra credit, you have some of it done, a lot of it done. Okay. Let me stop screen sharing for a moment. Okay, now let me share my screen, not my iPad. Okay, so before we started, one of your classmates mentioned that in your chapter 1 homework, I failed to list section 1.4. So I want to go ahead and let you know that I added that 1.4 to your assignment. So if you check out your assignment and you check out chapter 1 homework or weeks 2 and 3 homework, you have chapter 1. So 1.1, 1.2, 1.3, and that 1.4. 1.4 is just the odd problems. So all of the odds. I also want to show you that I added an extra module in the beginning. So at the very top, you have a module and it has your course schedule. So you have this in your syllabus, but I just thought it'd be nice to have this a click away. And we also have all of your homeworks. I'll add them bit by bit. So that way you have one single spot where you can see your homework. Yeah. Now, for the most part, does anyone have any questions on how to navigate Canvas or any other questions before we finish our Zoom meet?
Yes, I tried turning in the week 1 assignment, but it didn't go through on time. Like I turned it in during the day, but it didn't go through on time.
That's so weird. And that was before the deadline?
Yes, it was before midnight.
Okay. All right. Well, email me and I'll open it up for you so you can turn that in.
Okay.
Yeah. Any other questions before we sign off? Alrighty. Oh, that module 0, I see that says, where is that module 0? If you click on modules, it's the very top one, and that's it. That's where you can find that module 0. Okay. Alrighty, well, that's it for today. We'll have another one of these small Zoom meetings after chapter 2, so we can go through some problems together and hopefully you can ask your questions then. I also have office hours, so feel comfortable to stop on by. It's just me with the Zoom open, and if you have a question, you can log on. If there's people, then I'll have you waiting and I'll just say waiting for host, and that's it. I'll add you once I'm done. All right, have a nice weekend.
Thank you, bye.
Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you.